You know the operator for differentiation is like d by dx of. Okay. Just listen, when I write dy by dx or d by dx of any function, you need to understand the meaning of this one is differentiation of y with respect to x. Understood? From starting onwards. Okay, fine. Nothing. I didn't explain anything. I have just told you the synonyms for differentiation. Okay. Differentiation has so many names like slope, gradient, rate of change, derivative. Based on the application, we use those names. And integration. And integration has another name, which is called as antiderivative. What is that? Antiderivative. It is also called as primitive. Primitive means not English primitive, okay? Technical primitive, right? So actually, integration and differentiation are reverse process of each other. That's why we are calling it as integration. Understood? Okay, that is different story. First, let us try to understand what is differentiation. When I say dy by dx, the meaning of this one is differentiation of y with respect to x. Correct? Here, y is called as dependent variable. Just basic terminology, okay? Very quickly, I'll go to differentiation. X is called as independent variable. Y is called as dependent variable. X is called as independent variable, right? So basically, d by dx of when I write a function f of x, some function f of x, it is written as f dash of x. It is another symbol for differentiation. Understood? So I'll write down here d by dx of f of x is same as f dash of x. It is also same as f dot of x. Other same, different notations. Understand? Sometimes it can also be written as something like this, d f of x. That means differentiation of f of x. But most of the times we will use these two notations only. Don't worry. d by dx of f of x or f dash of x. Understood? Both are same. So this is the differentiation of the function f of x. Now, in physics, obviously, without these basic formulas of differentiation and integration, you cannot understand few concepts of physics. So without wasting much time, I look at some basic standard formulas which comes in differentiation. Okay. Standard formulas or formulae. Okay. First formula and very important formula, d by dx of x power m. What is the formula for this one? N into x power n minus 1. Okay. Next formula, d by dx of e power x. E power x. And e power x has one specific property. Even if you differentiate e power x any number of times, you will get e power x only. First differentiation, second differentiation, third differentiation. Understand? Even if you differentiate it n number of times, you will get again e power x only. Understood? Next one. What is d by dx of x? Obviously this is 1. How it is equals to 1? Using this formula. X power 1, right? Substitute n equal to 1. 1 into x power 1 minus 1, which is 1, because x power 0 is 1. Now, what is the differentiation of constant? Remember, differentiation of constant is 0. Why it is 0? Constant can be written as x power 0, right? d by dx of, let me take it as x power 0. X power 0 is 1. Isn't it? X power 0. I am just taking 1 as the constant. Use this formula. You will get 0 into x power 0 minus 1. 0 into something, 0. Is it clear? Now, so differentiation of constant is 0. It could be any constant. Now d by dx of ln x, logarithm of x, which is 1 by x. Understood? D by dx of a power x, a power x into log a, base c or ln a. When I write base e, it can also be written as ln a. Both are same. Understood? Ln means it is base e. Okay. Please remember this formula also. And here, if you replace a by e, you will get e power x into log e base e. Log e base e is 1. So that's why we are getting e power x. Clear? So these are the basic, formula for elementary functions. Now let us try to understand what is the differentiation of trigonometric functions. D by dx of sin x. This is cos x. Okay. Please copy this one first. Please copy. I will continue with the remaining formulas. Exponential 2.7. E power x constant. Okay, E net में expected the meaning of Okay, fine. A by dx of sin x is cos x. And if you don't remember this differentiation formulas, remembering integration formulas will be tough. If you remember differentiation formulas, it is very easy to remember integration. Okay. Now similarly, d by dx of cos x equal to minus sin x. Okay. Now d by dx of tan x, which is secant square x, right? Now, each and every formula can be proved, but as I said, we cannot prove it right now. We need some knowledge of limits, which I cannot tell you. It will take more time, right? D by dx of cot x minus cosecant square x. D by dx of cosecant x minus cosecant x into cot x. D by dx of secant x into tan x. So these are the very basic and standard formulas which we are going to use in physics. Okay, not in maths. In maths, we will go more beyond. Understood? So I think this is enough. These formulas are sufficient. In addition to these formulas, we need to look at some theorems on differentiation, which are very important. Theorems on differentiation. It is very simple. First one, if I want to find out d by dx of some constant c into f of x. C is a constant into function f of x. I can write this constant outside c into d by dx of f of x. Understood? Where c is a constant. Similarly, if I have, actually in physics, most of the times we take independent variable as t because we differentiate with respect to time, right? What is acceleration? Acceleration. Acceleration definition. Rate of change of velocity. I told you right, definition is nothing but rate of change, like dv by dt. So wherever there is x, we will just replace it by t when you are solving physics problems, right? So d by dx of f of x plus or minus g of x. I can take the differentiation individually. D by dx of f of x plus or minus d by dx of g of x. And these two formulas are very, very important. We call it as UV rule. If you want, we can write it as f of x into g of x, where u and v are functions of x. Okay. The formula for this one is u into differentiation of v, dv by dx, plus v into du by dx. Please remember this formula. Very often we are going to use this formula. d by dx of u equal to u into dy by dx plus v into du by dx. Can I erase this formulas? And one more rule, one more theorem, d by dx of u by v, d by dx of u by v. Okay. Now this is very simple. V into du by dx minus u into dv by dx by v square. This formula is also very, very important. Okay. Right. Now, in addition to the basic formulas of differentiation, we need to understand one more concept. Sometimes you'll get the application of this one. This is called as chain rule. I'll tell you what is the meaning of this chain rule. For example, if I have v by dx of x cube, what is the answer? 3 into x power 3 minus 1, right? N into x power minus 1, which is no doubt. If you have this type of functions, you can find the differentiation very comfortably. But if I have d by dx of, for example, sin x whole cube, how do you find the differentiation? In this case, you will get chain rule. The major significance of chain rule or application of chain rule is here independent variable is x. Here function is also in terms of x. In that case, you don't use chain rule, directly you'll get the answer. But here independent variable is what? X. But here function is in terms of sin x. In that case, we will use chain rule. Understood? Chain rule. Very simple. We will follow the basic definition only. Whatever you have here, any function, you treat this one as x. You treat this one as x. Again, I am not getting into the proof of this one. I'll just give you how to find the values of this one. When I start JE, I'll explain at that time. d by dx of sin x whole cube. Assume the sin x as x. Now, what is the differentiation of x cube? N into x power. In place of x, I have sin x into 3 power whole power 3 minus 1. But here, you need to do one more thing. Since here independent variable is not x, it is sin x, I have to multiply with the differentiation of that function, which is sin x. This will give me the complete answer. That is the meaning of chain rule. I hope it is understood to everyone. Clear my point? 3 into sin x whole power 3 minus 1 into differentiation of sin x. Because here you should perceive sin x as x. See here why I am not writing d by dx of x. Observe this one once. D by dx of x cube 3 into x power 3 minus 1 into again d by dx of x. Anyway d by dx of x is 1. That's why I am not writing it. But here you have to mention it because d by dx of sin x is not equal to 1. So answer will be 3 into sin x whole square. What is the differentiation of sin x? Cos x. That's not it. Understood? So this is the meaning of chain rule. Now let me give you one more application. Let me differentiate using t. T by dt of, for example, while solving physics problem I got something like this. Square root of t square minus t plus 1. D by dt of root of t square minus t plus 1. So how to find it? I told you right, whatever may be the function. See here we did not have t, another function. So I will write this one as t square minus t plus 1 whole power 1 by 2. Now I am just converting this one into x power n. This total thing is like x now. I hope you are following this chain rule. What is the formula? N into 1 by 2 into x. What is x here? T square minus t plus 1 whole power n minus 1 into differentiation of x. I told you, whatever function is there here, again you have to multiply with the differentiation of that function, which is t square minus t plus 1. Right? Now this is equal to 1 by 2 times t square minus t plus 1 time minus 1 by 2. Now, using that theorems are determinant, you can find the differentiation of individual functions. D by dt of t square 2t minus d by dt of t 1, d by dt of 1 0. So this is the answer. Understood? Now, I just want you to write down this one as also formula. It is useful. D by dx of root x. Please remember it. 1 by 2 root x. Again, how do you get this one? Using that basic formula, root x can be written as x power 1 by 2. What is the formula for x power n? N into x power n minus 1. So this is equal to 1 by 2 times x power 1 by 2 minus 1 minus 1 by 2. Now I can write this one as 1 by 2 times of x power 1 by 2, which is 1 by 2 root x. Sir, last formula, can't we do it as u d dv by dx plus 1 by b into. Okay, you want to apply UV rule only, Vishal? Yeah, we can, but you will get the same thing. Okay, good. I'll just clear your doubt. Vishal has got one doubt. He's asking for this formula. Can't we use this formula only? You can d by dx of, I think, according to Vishal, you want to write this one as u into 1 by v. Can I? U by v, you want to write it as u into 1 by v. Now this is u, this is v. Okay. Now apply this formula. What is the formula? U into d by dx of 1 by v, because in place of v 1 by v, plus 1 by v into d by dx of u. Vishal, you can do it. Now, in addition to d by dx of root x, please remember this formula also, because very frequently we will use this formula. D by dx of 1 by x minus 1 by x square. How do you get minus 1 by x square again? Write 1 by x as x power minus 1. N into x power n minus 1 formula. Okay. So you please remember these two formulas as special cases. D by dx of root x is 1 by 2 root x. D by dx of 1 by x is minus 1 by x square. Now, u into, what is d by dx of 1 by v? Just now I told you. Minus 1 by v square. Formula 1 by x minus 1 by v square. but into, here it is not in terms of x. So again I have to divide with, multiply with dv by dx. Understood now? This is chain rule. Plus 1 by v into du by dx. Now here if you take v square as LCM, here v times v into du by dx minus u into dv by dx formula. In fact, you can take it as the proof of this formula, right? Just copy all these formulas. Why chain rule when we have normal formula? Okay, Rohini, that's what I was telling you. When you get this type of situations, d by dx of sin x whole cube, you cannot apply direct formula. That will be wrong. Okay, it deviates from the very essence of the differentiation. Understood? Because d by dx of x cube is 3 into x square. But d by dx of sin x whole cube will not be 3 into sin square x. You have to multiply with again differentiation of sin x. Okay, understood? When you start JE, you will understand more clearly. For the timing, please remember. Just remember, try to understand where we have to use chain rule. That's it. And that will be sufficient for the time being. So these are the basic formulas. Copy. Right. So you just revise these formulas once again. Don't worry. When you start solving questions, the formulas will be remembered automatically. So you don't have to worry about that. I hope you understand when we have to use the chain rule application. Right. Let us try to look at some basic examples on differentiation. Very simple examples. Find dy by dx for the following. I think you already have this material, learn material, basic physics. Y equal to x power 1 by 2. Second one, y equal to x power minus 3. Third one, y equal to x. Fourth one, y equal to x power 5 plus x cube plus 4 into x power 1 by 2 plus 7. Fifth one, 5x power 4 plus 6 into x power 3 by 2 plus 9x. Sixth one, y equal to ax square plus bx plus c. And seventh one, y equal to 3 into x power 5 minus 3x minus 1 by x. One more point, sometimes differentiation is also called as differential coefficient. Please make a note of this one. Differentiation of a variable is also called as differential coefficient. Okay, they are very simple questions. First one, y equal to x power 1 by 2. What is dy by dx? Just now I told you. What is differentiation of root x? 1 by 2 root x. Second one, y equal to x power minus 3. Can you tell me what is dy by dx? N into x power n minus 1. Correct? So can I write this one as minus 3 into x power minus 4, which can be written as minus 3 by x power 4. I hope everyone is following. Third one, observe very carefully. What is dy by dx? 1. Fourth one, dy by dx equal to dy by dx of x power 5. 5 into x power 5 minus 1. Isn't it? N into x power n minus 1 plus 3 into x power 3 minus 1 plus 4. What is differentiation of root x? We'll write directly 1 by 2 root x plus differentiation of 7, 0. Differentiation of constant is 0. So this will be 5 times x power 5 minus 1, 4 plus 3 times x square. 2 2s are 4. So this will be 2 by root x. Just for understanding the formulas. Now what about fifth one? Fifth one you do it. Very simple. Sixth one also you do it, seventh one also you do it. Okay. One more question. Very simple. If s equal to t square plus 5t plus 3, find ds by dt. This is very easy. What about this one? S equal to t square plus 5t plus 3. Maybe displacement. Okay. So we just have to differentiate this displacement. ds by dt equal to. What is the differentiation of t square? 2 into t power 2 minus 1 plus 5 into differentiation of t 1 plus differentiation of 3 0. 2 into t plus 5. Very simple. Now find the differentiation of this one. X minus 1 into 2x plus 5. Similarly, 1 by 2x plus 1. 3x plus 4 by 4x plus 5. X square by x cube plus 1. Okay. Okay. Okay, 2 more minutes and then I'll stop. So look at that question. You want to find out d by dx of x minus 1 into 2x plus 5. You can do one thing. Either you can multiply this two and use differentiation, or use UV rule. This is u, this is v. What is the formula? U into dv by dx. That is d by dx of 2x plus 5 plus v into 2x plus 5 into d by dx of v, which is x minus 1. That is x minus 1 into. What is d by dx of 2x plus 5? 2. Because differentiation of 2x is 2, right? Plus differentiation of 5 is 0. I hope this is clear to everyone. Plus 2x plus 5 into. What is the differentiation of x? 1 minus differentiation of 1, 0. Now multiply with 2. 2x minus 2 plus 2x plus 5. 2x plus 2x, 4x minus 2 plus 5 plus 3. Now observe the second one. Application of chain rule. D by dx of 1 by 2x plus 1. Just now I told you, this is not in terms of x. This is 2x plus 1. Now assume this total thing as x. Okay. What is d by dx of 1 by x? Just now I told you, what is the formula? Minus 1 by x square. You remember that? D by dx of 1 by x is minus 1 by x square. But here in place of x, I do not have x, 2x plus 1. So according to chain rule, what should I do? I should multiply with the differentiation of 2x plus 1. Did you understand now? Is it okay? Now, next one. D by dx of 3x plus 4 by 4x plus 5. This is like u by v. So what is the formula? This is u. This is v. Formula v into, that is 4x plus 5 into d by dx of u. What is u? 3x plus 4 minus u into, that is 3x plus 4 into 4x plus 5 whole square. So can I erase this part? Last question you try. Same u by v rule. X square by x cube plus 1. So if you simplify this, 4x plus 5 times, what is the differentiation of 3x plus 4? 3. D by dx of 3x is 3 plus differentiation of 4 is 0. Minus of 3x plus 4 into, what is the d by dx of 4x plus 5? It is 4. Isn't it? By 4x plus 5 whole square. Now multiply. 3 4s are 12x plus 3 5s are 15 minus 4 3s are 12x minus 4 4s are 16 by 4x plus 5 whole square plus 12x minus 12x is cancelled. 15 minus 16 minus 1 by 4x plus 5 whole square. So these are the basic examples on differentiation. So if you have any doubts in basic differentiation, you can contact me. I'll stop it for today. Tomorrow I'll start with integration and I'll explain you the basic formulas. Thank you.